Hello, my name is Rady Mashhour. I'm an international student at University of Mount Union. I'm majoring mechanical engineering. I will be next year by junior. Today we'll talk about one of the subjects that will gonna be learned in the future on static and dynamics. The content of today will talk about the introduction of static and dynamics, and also we learned about some equations that some people doesn't know. Explain the powers and explain the efficiency, and we can solve some couple questions. Engine and motors are often rate the terms of their power of output, the power output of the motor lifting. This elevator is related to the velocity force, which is called F, acting on the elevator causing move upward. Given this desired lift velocity for the elevator with known maximum load, we can determine the power requirements of the motor. The speed at which a truck can climb and hill depends in part on the power output of the engine and the angle inclination of the hill. For given angle, how we can determine the speed of this truck, knowing the power terminated by the engine to the wheels. Then we have to know we can find the speed on the power. If we know the engine power output, the speed of the truck can determine the maximum of the angle of the climb of this truck. Power and efficiency. Power is defined as the amount of work performed per unit of time. If the mechanic or engine performs certain amount of work, delta U is called within given times delta T, the power generated can be calculated as center work can be expressed as delta U equal F, which is force, delta R is distance. The power can be written power equal delta U over delta T, which is also give us F multiplied by distance, give us over delta T, give us F delta R over delta T equal V multiplied by velocity. Through the power scale defined as the product of the force and velocity content as acting in the same direction. Using the scale of power can be written P equal V multiplied by F equal F multiplied by V cosine theta, where F theta is the angle between the force and velocity vector. So, if the velocity of the body can act on the force is known, the power can be determined by calculating the dot of the product or multiplying the force and the velocity. Now we have to know the units. The units of the power of SI system is watt, where 1 watt equal 1 joule per second, 1 Newton meter per second. In FPS, system power is usually expressed in units of HP, which 1 HP equal 550 feet per pound over second, which is give us 746 watt. Efficiency. The mechanical of the efficiency of the unit of the mechanics rate of usable power proceed output power to the power supplied to the mechanics, which is give us sigma power output over power input. If the energy input and removal occur at the same time, efficiency may be also expressed in the terms of the ratio of output energy to input energy, which is give us sigma energy output over energy input. Mechanics will always be function frictional force, since the frictional force dissipate energy. Additionally, power will be required to overcome these forces. Consequently, the efficiency of the mechanics always less than 1. Now, after we explained each equation from the power and the efficiency, we'll have some examples. The first example, give us a 150 kilogram block on A is hosting by pulley system motor M. The motor has efficiency of 0.8 at this instant, point P. On the cable has velocity of 12 meters per second, which is increased at rate of 6 meters per second squared. Now we have to find the power supplied to the motor at the instant. But before we're doing the calculations, we have to do some plans. First plan is we have to create a free body diagram of the block or even the entire question. 2. We need to use equation motions to determine the cable tension. 3. We can find the calculations. As we see here, the first one we did draw the free body diagrams. Here that is defined to point on the cable. Also SA or SA is defined only the lower pulley, since the block moves with the pulley. Two, the tension of cable can be obtained by applying the equation of motion to the block. Summation of y equal ma of AA. Let's see, ma is a mass and the a is acceleration. So 2t minus 50 multiplied by 2.81 meter per second squared, which is the gravity, or we can say the acceleration, equal 550 multiplied by 3, which is give us t equal 320.3 Newton. 3. Now we have done the power supply motor, the product of the applied to the cable. Now we have to find the power. So you have the V, which is the force, and the V, the F, the force, and the V is velocity. So the velocity is, we know as on the question, the 12 meters per second, and the force is going to be 320.3. So if we multiply together, we'll have the 3,844 watt. The power supply to the motor terminates using motor efficiency at the basic efficiency equation. So the P, which is, we have to find the PI, with the PI is the initial, so equal P, the power, over the sigma. So the 3,844 over the efficiency, which is 0.8, that give us on the question. So it will give us 4,804 watt. But we can convert it to be 4.8 kilowatt. Now we can move to the second question. For me, I will keep some students to do this question, but I will explain after some people will do it. So I will stop maybe 10 seconds to read the questions and do as we do it. I'll read the example. A 2000 kilogram sports car increased speed uniformly from rest 25 meters per second and 30 seconds. The engine efficiency, the sigma 0.8. We need to find the maximum, the power, the average power supply the engine. And as I explained, we need to do some plans before doing the calculations, which is the plans is to do the one free body diagram, to apply the equation of motion and kinetic equation to find the force, to determine the out power the required. Here we have to add one more because we need to find the efficiency to determine the input power. After I get some people think about the question, so we draw the free body diagram, the normal force NC and frictional force FC represent the results of force of all force wheels. The frictional force between the wheels and rod push the car forward. 2. Now we have to find the equation of the motion by summation f of x equal m to the x. As we explained before, m with the mass and the a is the acceleration. So minus 2000 gram multiplied by sine 5.711 plus fc to find f of x. To determine ax using constant acceleration, v equal v0 plus axt, which is the ax 25 minus 0 over 30. So we'll have the acceleration 8.33 meter per second squared. Substitute the ax on the equation of the motion, determine the frictional force. Fs equal 2000 ax plus 2000 gram multiplied by sine 5.711 is give us equal 2000 multiplied by 8.33 plus 2000. So the sine 5.711 on the calculation you will find is going to be 9.8 with the gravity. So the total is going to be 3,619 Newton. After we found the force, 3 we have to find the max power of output and the input. So the P out max equal VC V max, which is the 3,619 Newton multiplied by 25, which is the velocity, will give us 90.47 kilowatt. The average of the power output of the first time called the average speed, which is the P out of the average equal FC V average, which is 3,619 Newton multiplied by 25 over 2, which will give us 45.28 kilowatt. Last step, the power supplied by the engine is obtained using efficiency equation. The P input of the max equal P output max over the sigma, which is give us equal 90.47 over the efficiency, which is 0.8. It will give us 113 kilowatt. Then we'll do the same one on the average. P input of the average equal P the output of the average over the sigma. 45.28, 0.8 which is give us 56.5 kilowatt. I hope you learned some equations, and I hope you learned also how to use the power and the efficiency. And these are my reference, and I hope you enjoy my lecture. Thanks.